Hi everyone, I'm the sleepy scientist. Tonight we're going to drift together through the fabric of something you live inside every moment, something no one's ever seen, touched, or tasted, something so obvious that it hides in plain sight. We're going to talk about space and time, and how they might not be what you think they are at all. But before we get lost in the infinite, I'd love to know where in the world you're listening from and what time it is for you. Let me know in the comments below. I'm always curious where these quiet little science stories are drifting to, and if this video helped you while you were there. Now relax, take a deep breath, and join me gently on this evening's journey. You shuffle slowly through your dark room bare feet, whispering across a cold floor. There's a glow outside, distant headlights maybe. The digital clock on your shelf reads 2:49 a.m. You blink. It changes to 2:50. But something feels off. What if time didn't actually pass? What if, just maybe, the clock lied, sure the numbers flipped. The minutes fell like crumbs behind you. But you didn't see time. You felt a heartbeat. You heard the hum of your fridge, maybe. But where was time, really? That's the first trick of the universe, the clock that wasn't there. You check your phone. It confirms the betrayal. 2:50. But has anything real changed in the world? Or did we just agree to slice our lives into seconds and stick them to the wall? You're not alone in this suspicion. Some physicists whisper about it late at night over coffee-stained whiteboards. Time might not be real, at least not in the way we think. You've probably heard this saying. Time is what keeps everything from happening all at once. It's clever. But what if things do happen all at once and it's just your brain smoothing them out like butter on toast? You remember a moment from earlier today, a dog barking. The moment feels before this one. But where is that before? Can you reach into your pocket and pull out yesterday? Of course not. You remember it. That's all. Memory is a magician, and you're the volunteer. The brain stacks slices of experience and then tells a story to tie them together. You woke up. You made toast. You went to work. You blinked. And now it's night. But what if the story is fiction? Odd fact break, in the 1800s, trains were the reason time became standardized. Before that, each town just kind of winged it. Noon was whenever the sun was overhead. Then trains started crashing because nobody could agree what time it was. So humans invented time zones just to stop the accidents. That's right, clocks didn't get real until trains got fast. And maybe that's the clue. Speed. You sit down on your bed and stare at the wall. You're not moving. Nothing's changing. There's no sound. For a moment, it's like you're floating in a still painting. If you stood there forever, no heartbeat, no breath, no brain. Would time exist? Here's where it gets deliciously weird. Scientists still debate whether time flows or just feels like it does. One camp says time is real, it ticks forward unavoidable, like a film reel, one frame at a time. The other camp, they say time is like the film itself. All the frames already exist. You just happen to be looking at one right now. Tomorrow's frame is already there, you just haven't seen it. Like walking through a photo album where every page already exists. You just think the pages are turning. But then what about change? You remember walking, aging, growing. Well, the brain is a sticky sponge. It doesn't just store memories, it creates the sensation of flow. That sensation of before and after is maybe the only proof time exists at all. Imagine watching a spinning fan. The blades blur into a shape that isn't there. Stop the fan, and suddenly 4 individual blades, clear, Still, real. Is the blur a thing, or just your eyes struggling to keep up? That might be time. A blur, a motion illusion, a cognitive smear. Here's something to cradle in your thoughts. Some quantum theories say the universe doesn't care about time. It just exists as a big static equation. No ticking, no talking, just everything everywhere all at once. Sorry. Michelle Yeoh, the physicists, got there first. And yet, we live like time is real. Alarms, deadlines, birthdays. We feel it rushing. We mourn its loss. I don't have enough time, we whisper crumpled on the kitchen floor. But the atoms in your body, they don't know what a Tuesday is. The photons in your ceiling light, they don't age. Only you do, or think you do. And so here you are, still, awake, wondering if the last hour actually happened, if it's happening right now somewhere else. What's more real, the clock on your wall, or the sensation of your fingers going cold in the night? Maybe both, maybe neither. Maybe you're just standing in a memory that hasn't ended yet. And the best part, you'll never know for sure. You can't touch a second. Not one. Not even with tweezers. You try sometimes without knowing it. You race to catch the train, squeeze in one more message before your meeting, delay your alarm by just 5 more minutes. But no matter how tightly you clench your fists, the seconds slip right through ghosts in a room full of furniture. And that's the strange thing, we behave like time is a substance, like it's real, like it's a thing you can have or waste or lose. But tell me, where does a second live? Not in your watch. That's just gears or silicon mimicking a heartbeat. Not in your calendar, that's paper pretending to be destiny. Not in the sky, not since we gave up on sundials and started worshipping quartz crystals. No, a second isn't anywhere. It's everywhere. And it's nowhere. And it's also completely made up. Okay, not completely. We had to agree on something, right? Enter the second, officially defined as 9,192,631,770 vibrations of a cesium-133 atom. Yes, that specific, that absurd. That's what makes your phone know what time it is. That's what makes New Year's countdowns semi-legit. Tiny atomic spasms. That's your life. And yet, can you feel a second pass? Can you touch one? All you feel is the space between things, the silence between footsteps, the pause before a laugh, the aching eternity between when someone says we need to talk and when they actually talk. Odd fact detour. Your brain lives slightly in the past. Every sensation you feel, touch, sight, sound, is already a little outdated by the time you're aware of it. Like watching live TV with a 2-second delay. So technically everything you've ever felt has already happened, which means you've never really lived in the present. Spooky, right? And still you're here. Listening. Sensing. Believing in the rhythm of time even as it ghosts you. But the universe, it doesn't even own a watch. When physicists write the equations for how stuff moves, planets, atoms, cats, they often don't need time. They just calculate relationships. This thing does that when this other thing does this. Time doesn't steer the ship, it's more like a shadow the ship leaves behind. And yet, we keep asking, what time is it? Try asking instead, what's happening? It's a different kind of awareness. One where you're not ruled by numbers on a screen. One where you become a little more like a tree. Trees don't know it's Tuesday. They just bloom when they're ready, but you chase time like it owes you something. Still, there's a reason we cling to it. Because without time, things get messy. What happened first? What causes what if you're baking cookies and the oven turns on after the dough is already warm? We've got problems. Causality, that precious little thread we hang all of reality on, demands that time moves forward. One thing leads to another. But even that, not guaranteed. Scientists still debate whether causality is truly baked into the cosmos, or if it's just a side effect of our limited view. Like watching a movie through a toilet paper roll, you think you know what's going on, but really, you're just catching one scene at a time. And sometimes the scenes play out of order. There's a concept in physics called time symmetry. It means that technically, the laws of physics work the same whether time moves forward or backward. Imagine dropping a glass. Shattering. Now rewind it. The shards leap up and form a hole again. According to the equations, totally fine. It's just your brain screaming, nope, because it's not how things feel. Because memory only goes one way. Which leads us to the strangest thing: if time is just a feeling, then so is everything that happened today. Breakfast. That weird meeting. The moment you stared into the fridge and forgot why you opened it. All of it just sensations wearing time costumes. You look at the wall now. You know it was painted last year. You know that. But try to hold that year in your hand. Try to squeeze it like dough. All you'll find is now. Always now. And this now keeps on slipping. A little joke to soften the brain cramp. If time is money, why is my wallet always empty and my calendar always full? Pause. Listen. That was a second. Gone. Did it really happen? Or did you just agree it did? Time plays favorites too. It speeds up when you're having fun. Slows down when you're waiting for someone to text you back. Warps when you're nervous, stretches when you're grieving. And we treat this warped sensation like it's fixed. But it's not. It's liquid. It flows between your fingers and sometimes it stings. And yet here's the comfort in the absurdity: even if you can't touch a second, you can feel the echo it leaves behind. A heartbeat. A breath. The warmth of someone's palm that's no longer there. So maybe it's not about counting seconds at all. Maybe it's about noticing the space between them. Your feet are always late. Even if you sprint, even if you jump out of bed with cartoon urgency, the truth is, they never quite keep up. You wouldn't notice unless someone told you. Unless they asked, hey, did you know that your head is older than your toes? No joke. Because the faster you move or the deeper you sit in a gravity well, the more time does its weird, slow, stretchy thing. Let's wind back a bit. Imagine two twins, identical, irritatingly fit, the kind that eat raw kale for fun. You send one twin on a rocket ship. They loop around the galaxy at near light speed, while the other twin stays here munching cereal and paying taxes. When rocket twin returns, they're younger. Not just looking younger, being younger. Their body, their cells, their very time has passed more slowly. This is Einstein's time dilation, the weirdest birthday prank in the universe. Here's the kicker: it's not a theory anymore. We've tested it. Astronauts on the ISS zipping around Earth at crazy speeds come back a smidge younger than their ground-bound colleagues. Not enough to skip wrinkles, but enough to make you pause. It gets even weirder when you consider gravity. The more gravity you feel, the slower time moves. That's right, clocks tick more slowly, the closer they are to Earth's center. Which means your head sitting farther from Earth's core than your feet actually experiences time a tiny bit faster. So yes, your head is older than your toes, only by nanoseconds, but still. Weirdly true. You wiggle your toes in the dark now. Feel them. They're slightly younger, a bit fresher, like leftovers you forgot were in the fridge. Odd fact time. There's a mountain in Ecuador called Chimborazo that sticks out farther into space than Everest, because Earth bulges at the equator. That means if you want to age faster, technically, take a nap up there. You'll get a few extra femtoseconds of life. Now back to your regularly scheduled confusion. So why does motion slow time? Here's the metaphor that physicists sometimes whisper into their pillows. Think of time as a budget. You get a fixed speed to spend on movement through space-time. If you spend more of your budget moving through space by going fast, you have less left to move through time. So you age slower. It's like trading aging for speed. But if you sit still like you are now cozy and horizontal, you spend almost nothing on motion through space. So all your budget goes into moving through time, you're aging at full speed. Congrats! So even sitting still, you're not really still. You're racing into tomorrow at the maximum rate allowed by physics. Scientists still debate what time really is, but almost everyone agrees on this: space and time are not separate things. They're space-time, a four-dimensional fabric you're sliding through whether you feel it or not. It's like you're lying on a sheet. You think you're stationary, but the sheet itself is stretching and twisting and carrying you forward. And when you move across that sheet faster or slower, your personal path through time warps. You don't feel it, but you live it. Here's the practical part. Your phone's GPS has to compensate for time dilation. Satellites orbiting Earth move fast and sit higher in gravity's grip. Without correcting for Einstein's equations, your Uber Eats would show up at your neighbor's house. So yes, relativity delivers pizza now. And in that absurdity is a kind of comfort. You lying here are proof that the universe bends to your motion. You're not just floating through time. You're pulling it, shaping it, nudging it as you move, even if you never leave your bed. So next time someone says, "Time flies," you can answer, "Only if I do. Here's something to melt your brain before bed. If you could reach light speed, time would stop. For you. The rest of the universe would keep aging, dying, being dramatic, but you'd be frozen in one eternal now. And for light itself, like the photons coming from that star, you can just barely see out your window. There is no time. The moment it leaves a star and the moment it hits your eye. Simultaneous. To light, distance and duration are meaningless, which means you just caught the end of a journey that from light's perspective never took place. A joke before you spiral. If Einstein walks into a bar and orders a beer before he arrives, did the bartender age? So here's where you rest. Knowing your body is secretly time traveling. Your feet, younger than your thoughts. Your dreams, aging faster than your pulse. You're not broken. You're just woven into a reality that bends when you run. And the next time you're late for a meeting, just tell them it's relativity's fault. The room shrinks when you run. Not metaphorically, though. Yes, sometimes a room feels smaller when you're panicking in it. No, we mean this literally. According to the laws of physics, the faster you move through space, the shorter that space becomes for you. It's called length contraction, and it's one of the more no way that's real results of Einstein's theory of special relativity. But it is real. Very real. Here's the setup: you're on a train. A sleek, quiet, impossibly fast train. It's zipping along at close to the speed of light, and you're standing in the aisle eating a banana. Because of course you are. From your point of view, the train feels normal-sized. The banana is as awkwardly shaped as always. But someone standing outside the train, let's say a calm cow, watching from a grassy hill, would see something different. To the cow, the train has contracted in the direction it's moving. It's shorter, squashed. Like physics hit it with a shrink ray, but only from the side it's racing toward. Weird, right? The banana shorter, too. You, a bit compressed flatter in the direction of motion. Don't worry, you still look great. But here's the truly mind-melting part: you don't notice it at all. From your perspective, nothing's changed. Your world feels stable and unchanged. It's only the outside observer, the cow, let's say, who sees the squish. And the faster you go, the more you contract. At light speed, you'd be squashed into zero length, a dot. But don't worry, you'll never get there. Nature has a speed limit: 299,792, 458 meters per second. No matter how much caffeine you chug, no matter how fast you try to sprint into next week, you'll never quite touch light speed. It's always just 1 second ahead. Odd fact: break muon's tiny particles created when cosmic rays slam into Earth's atmosphere shouldn't reach the ground. They decay too quickly. But because they move so fast, time for them stretches, and the distance they need to travel contracts. Thanks to relativity, they make it to the surface. If it weren't for length contraction, you'd never meet a muon. But you did. So score 1 for physics. So what does this all mean for you? Well, the very idea of space being a fixed backdrop, like the stage beneath your life, isn't quite right. When you move fast enough, space itself adapts. The distance between here and there is flexible, squishy, negotiable. It's like the universe whispers, "Oh, you're in a hurry, wool. I'll move the finish line closer for you." Scientists still debate the philosophical meaning of that flexibility. Does it mean space isn't real, or just that our measurements are always tangled up with our movement? Are we discovering something fundamental, or just running into the limits of our language? Either way, it's a reminder: you're not walking through a frozen grid of space. You're sliding along a bendy, stretchy surface that adjusts itself depending on how you're moving. A fabric. And speaking of fabric, let's say you're sprinting toward your bedroom door. You won't notice the hallway get shorter. But from a distant observer's point of view, the hallway did shrink. Just a bit. That means space is not absolute. It's relative. Relative to you. You are the ruler, the measuring tape. And every time you move, the universe recalibrates its geometry around you. That's oddly flattering, isn't it? Here's a joke to fold into your pillowcase: why did the relativistic duck cross the road? Because from his perspective, the road was only 3 inches wide. But there's also something humbling in it. Because it means we're not just passive passengers in the universe. Our motion changes things. Our velocity rewrites the map. Even when you're late for the train, and your coffee is cold, and your shoelace is untied, you're affecting the very fabric of reality. You're not small. You're slippery. And the universe? It's surprisingly flexible. Of course, in your everyday life, you don't feel this. We all live at snail speed compared to light. You'd have to move at significant fractions of light speed for length contraction to get dramatic. That's why trains don't flatten. That's why your banana stays appropriately banana-shaped. But the principle stands. And it adds to this growing unease, or maybe delight, that the world is not as it seems. The room shrinks when you run. Your feet age differently than your head. Time stretches and curls around mass, and through all of it, you're just trying to get your socks to match. So tonight, as you lie there motionless, think of it this way: your stillness is sacred. You're giving space a break. You're letting the hallway be full length. You're letting bananas stay bananas. But should you ever decide to move fast, you'll bend space itself. And maybe, just maybe, you'll shrink the room just enough to reach what always felt out of reach. The silence of absolute stillness. You lie there now, not moving, not even a twitch. Your body feels heavy, soft, slightly melted into the bed like a forgotten candle. But imagine what if nothing moved, not just you, not your lungs, not your heart, nothing. The entire universe. Frozen. No particles jittering. No atoms vibrating, no light zipping by, no sound, no breath. Just one eternal, unmoving frame. Would time still exist? You probably guessed the answer by now. Maybe not. Because time, as far as we can tell, only makes sense when things change. Time is what we call the difference between this and that, between one configuration of the universe and another. No change, no difference. No time. Scientists still debate whether time is dependent on change or if it's the backdrop against which change plays out. Like is time the stage or just the echo of movement? But let's say we go with the extreme idea, no change equals no time. Imagine it. A cosmos caught mid-blink. Galaxies hovering like bubbles in amber. Suns never burning. Lovers never kissing. Electrons frozen around their nuclei like moths glued to lamps. It's eerie, isn't it? Odd fact break, supercooled atoms chilled to near absolute zero can stop moving so much that they begin to behave like one single quantum object. 1,000 atoms breathing together like one. That's not exactly timelessness, but it's flirting with the idea. The closer you get to absolute stillness, the more time begins to hesitate. Now let's come back to your room. There's still air brushing your skin, dust drifting in quiet spirals, blood whooshing gently through your veins. Your eyes, even closed, flicker with micromotions. You are not still, not truly. But what if you could be? What if just for a moment you became absolutely unmoving? What would remain? No heartbeat, no thought, no awareness. Just a human-shaped statue nestled in a universe of static. And in that moment, would there be any before? Would there be any after? It's possible that time in that perfect stillness vanishes, because you only sense time passing when you can compare. This moment versus the last. This breath versus the next. But if there is only one moment and nothing ever shifts, how can you tell it's not eternity? There's a name for this thought experiment. It's called a block universe. In this idea, every single moment, past, present, future, exists all at once, like frames in a film reel. They don't change. They just are. We experience the illusion of time because our consciousness moves across the reel like a flashlight. But the film, it never changes. Every version of you, age 5, age 27, age 91, is already printed somewhere in the reel, just waiting for the light to pass over them. You're not in time. You're of time. A structure built into the four-dimensional geometry of space-time. That's comforting, or horrifying, or both. But it does explain something curious, why we can remember the past, but never the future. If time is just a landscape, then we're only facing in one direction. Facing backward means memories. Facing forward means mystery. Here's a sleepy joke. What did one photon say to the other in a timeless universe? We'll always have right now. You stretch a little, feel your body melt further into the bed. That stillness, partial though it is sacred. Because even when nothing happens, something is happening. Your atoms are still dancing even in silence. The room breathes gently around you. The fridge hums. Somewhere a car rolls past, never knowing it's disturbing a philosophical insomniac trying to freeze time. But don't worry, you're not the first to try. Monks, mystics, physicists, they've all attempted to pierce through the moment and find what lies beyond motion. Some say they've glimpsed timelessness. Some say they've lost their sense of self in it. And some say that's all nonsense. But you don't have to believe anything tonight. You can just imagine that maybe under all this ticking and swirling, The universe contains a moment that never began and never ends, a perfect frozen now, untouched, undisturbed. And maybe in dreams you've been there. Maybe that's why sleep feels so strange, so disconnected. Because in some tiny corner of your brain, everything pauses. Thought, identity, memory, all taking a breath. Time loses its grip. And in that stillness, something ancient stirs. Something that doesn't tick or talk or count. Something that simply is. So lie still if you want. Try to find the quiet place where even time forgets to move. And maybe, just maybe, the universe will sit there with you. For as long as you need. Space is just relationships. Not friendships. Not situationships. Not awkward texts at 2 a.m. No, I mean something quieter. Stranger. Deeper. We often think of space as stuff that's empty. A big black box. A blank canvas the universe is painted on. But more and more scientists are beginning to say, nope. Space might not be a thing on its own at all. It might just be a way to describe how things relate to each other. Here's what that means. When you wake up one morning in a white room. No walls, no floor, no ceiling, just white. You float there alone. No window, no door, nothing but you. How do you know if you're moving? You don't. You can't. Because motion, like distance, only exists between things. No things equals no between. No between says no space. Which means space isn't just emptiness. It's the network of relationships between objects. It's a map of how everything connects. And if nothing exists in it, then it doesn't exist either. Odd fact break. In quantum mechanics, particles don't have defined positions until they interact. That is, their location in space isn't even real until they bump into or get measured by something else. Until then, they're smeared out clouds of probability. So in a way, space is what becomes when things start interacting. When particles shake hands and say, "Hey, nice to meet you. I guess I'm here and you're there." But until then, there's no here. There's no there. There's just potential. This idea freaks people out, even scientists. We like to think of space as fixed and solid, like a grid on a video game map, always there whether the characters are standing on it or not. But more and more physicists lean toward the idea that space is emergent, that it comes into being from something deeper, some primal code, some tangled mesh of numbers and probabilities, and relationships we don't yet understand. They call it relational space, and it's very polite, because it always asks, who are you standing next to, before it tells you where you are. Here's something weird to let melt behind your eyelids if the entire universe were to double in size right now. Every atom, every planet, every neuron, every measuring stick, would you notice? Nope. Because the ratios stay the same. Space is relational. It only matters if something's farther than something else. Without comparison, size and distance are meaningless. Scientists still debate whether there's any absolute background to space at all, or if it's just one big codependent party where nothing exists except in relation to everything else. If that's true, then you're not just in space. You are part of the definition of space. Wherever you are right now, curled in bed, couch-dwelling like a starlit gremlin, maybe even brushing your teeth in some eternal late-night loop, you're helping define the structure of reality. Your mass, your position, your relationship to the walls and the cat and the moon. You're part of the network. That's kind of beautiful, isn't it? Space isn't the backdrop. It's the conversation, and you're a word in it. Here's a sleepy joke. What did one particle say to the other in relational space without you? I'm nowhere. Now zoom out a little. When Einstein talked about spacetime, remember the stretchy fabric we imagined it as this thing we exist inside of. But maybe it's not a container at all. Maybe it's a language, a mathy kind of poetry that just describes how stuff interacts. No interactions, no story, no spacetime. Which raises a haunting little question. If space is just relationships, then where does that leave you? Who are you when you're alone? Are you still somewhere? Or does you require a contrast, a world to push back to say you are not me? Maybe space, like identity, is just a set of distances between things. You and your childhood home. You and that friend you don't talk to anymore. You and the moonlight slipping under your curtain. It's all one lattice of distances, and you are a node in that web. So as you drift into sleep, remember you're not falling into emptiness. You're not floating in some cold, meaningless void. You're nested inside a cosmic network of relationships, defined by how you tug on others and how they tug on you. You are here because everything else is, and everything else is because you are here. The warped blanket beneath you. You probably think you're lying still. Body against mattress. Mattress against floor. Floor nailed into the bones of the earth. But gravity has different plans, and space is not taking the night off. Right now, this very moment, your body is subtly leaning into a dent, an invisible bowl in space-time, one carved out by the mass of the earth. You're not being pulled down. You're falling into curvature. That's gravity. Not a force. Not a magnet. Not a mysterious tug from below. Just a warp. Einstein's grand epiphany was this: mass tells space how to curve, and space tells mass how to move. Let that echo for a second. Not push, not pull. Just movement along bent paths. Apples fall not because the earth reaches up and yanks them, but because they're rolling downhill on a curved bit of reality. You're doing it right now. Lying there like a sleepy boulder on a trampoline of space-time. And that mattress under you, it's part of the indentation. You're not above space. You're inside its curvature. Odd fact break: if you put a GPS satellite in orbit and don't account for general relativity, your location will be wrong by about 10 kilometers a day. That's how much time and space bend differently up there. GPS has to run 2 separate clocks, one for speed and one for gravity, to keep your pizza delivery accurate. Yes, your ability to get tacos at 2 a.m. relies on Einstein being right. Bless him. And what causes the dent? Mass. Just existing. The more mass you have, the deeper the dent. The sun warps space-time like a bowling ball on a waterbed. The Earth less, but still enough to pull oceans into tides and satellites into orbit. You make a tiny dimple, barely a wrinkle in the fabric, but it's there. Which means in a very real way, you affect the shape of the universe, just by being, by lying there, existing, being slightly heavier than a ghost. And what about black holes? Ah yes, the drama queens of the cosmos. Black holes are what happen when so much mass gets shoved into such a tiny space that the dent becomes a well, a cliff, a tear in the sheet. Not a hole in space exactly, more like a place where the curvature becomes so extreme that even light can't climb back out. Inside that well, time itself slows. And if you could somehow perch at the edge, what physicists call the event horizon, you'd watch the rest of the universe speed up. Stars would zoom by like fruit flies. Civilizations would rise and fall. TikToks would go extinct. And you'd hardly feel anything at all. Scientists still debate what happens inside a black hole. Some say information gets destroyed. Others insist it must somehow be preserved because quantum rules throw a hissy fit if it isn't. Some whisper about firewalls or quantum fuzz or holographic event horizons. We don't know, we probably can't know. But we do know this black holes prove just how bendy space-time can get. And that's the same fabric you're currently tangled in, wrapped like a sleepy burrito on your bed. Here's a joke just to break the void. What's a black hole's favorite pickup line? Hey baby, are you light because you're not escaping me? Okay. Back to our quiet drift. Your body feels still, but underneath the earth is pulling the moon into tides. The sun is corralling planets with elegant gravity leashes. The galaxy is curling in slow spirals, all of it dictated by the gentle sagging of space-time under mass. Gravity isn't a mystery anymore. It's a map, an instruction sheet in the shape of curves. Every motion, your breath, the swirl of steam from a teacup, the orbit of an exoplanet, is just someone following the dips in the terrain. And that terrain, it's not separate from space. It is space. A shape, not a substance. A twist, not a thing. So as you lie there, feel it not as pressure, but as direction. Gravity isn't pushing you down. It's showing you the path of least resistance. And your body, wise as ever, is just following the line. Sleep isn't falling. It's surrendering to curvature. And your dreams, maybe they're just what happens when your mind stops resisting the warp. So drift. Let the universe wrap around you like the warped blanket it's always been. And know that wherever you go, however slowly, however gently, you're tracing curves written by the stars themselves. There's no now nowhere. You might think there is. After all, you're here. You're now. The clock says so. Your breath says so. Your brain is quietly ticking like a metronome in slippers. But the universe, it's not on the same page. Because the moment you try to define now beyond yourself, everything starts to break. There's no universal clock. No cosmic narrator announcing, ladies and gentlemen, it is officially now. There's only your now, their now, my now, and none of them match exactly. Here's why: the faster you move, the more your sense of now shifts. This is called the relativity of simultaneity. And it's one of those concepts that sounds made up until it punches your brain in the math. Imagine two lightning bolts strike opposite ends of a train at the same time from the perspective of someone standing on the platform. Perfectly synchronized. Boom, boom. But someone inside the train moving forward would see the bolt at the front before the bolt at the back. To them, it wasn't simultaneous. The bolts weren't friends. The past and the future got scrambled. Same event. Different now. Odd fact: Einstein first imagined this exact lightning train scenario while riding a streetcar in Bern, Switzerland. He looked at the clock tower and wondered if the light from the tower would hit everyone equally if they were all moving. That question unraveled reality as we knew it. So here's the unsettling truth: there is no one unified now that everyone shares. What's happening right now for you might already be history or not yet future for someone moving differently in space. And this isn't just some trippy brain exercise. It's physics. It's built into the equations. Scientists still debate whether time is even a real thing at all, or just a byproduct of how we slice up experience. And simultaneity, that's even more fragile. Because if you can't agree when things are happening, how do you even define cause and effect? Here's a thought to chew on sleepily. If an alien on the far side of the galaxy moved fast enough, they could consider your future as their present. Your yet to happen might already be their yep that happened. So are you ahead of them, behind them, or just on a totally different timeline map? There's a joke for this. Obviously, I tried scheduling a meeting with someone across the galaxy, but we couldn't agree on what day it was, or century. What this really means is that now is local, a personal bubble. A story you tell yourself based on what information has arrived and how fast. You look out the window and see the moon. That's not the now moon. That's the 1.3 seconds ago moon. You call your friend and hear their voice seconds late. You watch a star and see light from before your country existed. Every now is a remix of signals arriving at different times. You live in a delay. A beautiful one, yes, but still a delay. And yet, we feel present. We feel like we're in this moment, because our brains are built to ignore the lag, to smooth it out like peanut butter over the jagged toast of spacetime. So you get this illusion of here and now. But it's just that. An illusion. The truth. There's no master clock. No single now. Just a smeared-out lattice of events, each with their own neighborhood of present, depending on where and how they move. It's like trying to name the top of the ocean. It depends where you're floating, and which wave you're on, and if your duck floaty is drifting. Now think about what that means for communication. If two people are moving fast enough apart, their nows diverge so much that messages from one could arrive before the other sends them. Causality gets weird. Time travel gets mathematically plausible, though not practically useful unless you enjoy exploding. But you right now, you're just curled up in one tiny patch of the cosmic quilt. Your now is yours alone. So don't stress about the galactic calendar. Let your now be soft. Let it be fuzzy around the edges. It doesn't have to be accurate. It just has to feel real enough to dream in. And as you slide into sleep, you'll drift deeper into that personal bubble. Time will slow. Moments will blur. And all the other no's will fade away. Because right now for you, this is the only moment that matters. And it's exactly where you're supposed to be. Time only moves forward, we think. You're probably nodding already, of course it does. You age, bread molds, coffee cools, YouTube comments pile up like digital fossils. Things move forward, not backward. But why? No, really. Why does time have a direction at all? Because if you ask the laws of physics, they'll shrug and say, doesn't matter. Most fundamental equations work just as well if you flip time backward. Particles bounce the same atoms, obey the same rules. Gravity still curves things politely. So why do you feel like you're being pushed along a one-way conveyor belt? Enter entropy. Entropy is a fancy way of saying things tend to go from ordered to messy. A glass falls and shatters. Your desk accumulates mystery crumbs. The universe goes from neat and tight to chaotic and scattered. It's the one thing that really truly prefers forward. And scientists think that might be where the arrow of time comes from. Not from some magical ticking, but from the universe's deep, primal craving for disorder. Odd fact break. When eggs rot, their molecules become more disordered, but the total energy stays the same. Entropy is about arrangement, not amount. That's why unbreaking an egg is impossible, even though the molecules are still technically all there. So time might not be pushing forward because of some cosmic rulebook. It might just be sliding downhill into chaos. Your memories are little postcards from low-entropy states, moments of structure, of clarity, of before. And each new second adds a bit more noise, a bit more mess. That's why you remember the past, but not the future. The past is ordered. The future hasn't happened, or rather hasn't degraded yet. Scientists still debate whether entropy really explains everything about time's direction. Could there be a deeper reason? A missing puzzle piece? Maybe the universe started with a freakishly low entropy bang, and we've been unraveling ever since. Or maybe memory is the illusion. Maybe everything happens all at once, and we just sort it like a toddler with blocks. Here's the brain-hugging idea: you never actually experience time passing. You just wake up in a slightly different brain state with a story that says, "Ah, yes, I remember brushing my teeth." Memory creates the illusion of a continuous self. Remove that memory. Remove the sense of time, which brings us to dreams. You ever notice how dreams are untethered by time's arrow? Things shift, loop, overlap. One moment you're in your kitchen, the next you're riding a dolphin made of soup. There's no forward, just now, now, now. Time in dreams is like fog. You move through it, but it never moves past you. Maybe dreams are what existence looks like when we stop pretending time is strict. Here's a soft joke. Why did entropy break up with time? Because I need space to fall apart on my own. Now let's flip things. What if time could go backward? What if one day your body started to unage, your memories rewound? You climbed back into the womb like a salmon returning upstream. The laws of physics wouldn't scream. They'd shrug. Mathematically, it's possible. But emotionally, psychologically, it's horrifying. Because our identities, our selves, are built from the illusion of progress, of becoming, of heading somewhere even if that somewhere is just lunch. If time turned around, who would you be? There's one experiment that makes physicists giggle. They simulate time reversal in quantum systems. Tiny particles being played backward like a tape. And sometimes, just sometimes, the system doesn't notice. The math still works, but only on tiny scales. Big, messy systems like brains, pizza, the internet don't handle reversal well. Too many variables, too much noise, too much entropy. So yes, time only moves forward. Probably. Because going backward would require too much remembering, too much perfection, too much order. And this universe, it prefers chaos. So tonight, as you lie there, let time keep walking forward. Let it carry you like a river. You don't need to paddle, just float. And know that the reason you wake up older, the reason coffee gets cold, the reason you never remember the future, is because you're surfing entropy's wave. It's not cruel. It's not wrong. It's just the direction the universe loves most. Forward. Always forward. You are a worm in space-time. No offense. It's just the best metaphor we've got for the very strange thing that is. You stretched across time. Let me explain. You often think of yourself as a point, a single moment, a single location, a little glowing pin of awareness sliding along the calendar like a bead on a wire. But physics sees you differently. In the four-dimensional fabric of space-time, your life isn't a series of dots. It's a single, elongated, unbroken line. A worm, if you will. Not squishy, not slimy, but unmistakably extended. From your first cry to your last sigh, your whole existence is one continuous thread already woven into the universe's geometry. Every version of you, the child with scraped knees, the awkward teen, the sleepy person listening to this right now, is already in the fabric, just in a different slice. Odd fact break. In space-time diagrams, physicists often draw people and objects as world lines. A ball tossed into the air. That's a curved line arcing upward and falling down. A person lying still. That's a vertical line through time. So yeah, you're a line now. Congratulations. So what does that mean for you? Well, it means you're never just here. You're also there, and back there, and ahead. All the US that ever were and ever will be are part of your space-time worm. From outside the fourth dimension, your life would look like one elegant swirl, a glimmering thread twisting through the universe. No cutting, no editing, just everything. Scientists still debate what this really means. Is the future fixed? Are you doomed to follow a pre-written path, unable to turn left when the timeline says turn right? Or is this just a mathematical trick, one way to represent data without saying anything about destiny? Nobody knows. But the metaphor holds. You are not a snapshot. You are a shape. And that shape includes every moment you've forgotten, every moment you've longed for, every breath you'll ever take. Now here's a sleepy side joke. What did one space-time worm say to the other? Stop stretching the truth, you're making me look long. Let's zoom in. When you look at yourself in the mirror, you're seeing one slice like a cross-section of a loaf of bread. One layer of the full loaf that is you. But there are slices ahead, ones you haven't felt yet, and slices behind crusty and nostalgic. From the perspective of a four-dimensional observer, all those slices exist at once. They don't come and go, they just are. A complete sculpture made of time. In fact, this is what the block universe idea is all about. Time doesn't move in this view. There is no past or future, except as places along the worm. So what moves consciousness? You, or rather your awareness. You're the flashlight scanning along your own length, illuminating one frame at a time, giving yourself the illusion of a story, the illusion of change, of memory, of progress. But the rest of you, the full worm, it's always been there. So when you remember being 8 years old, jumping into a pool in slow-motion water folding over your ears like cool cloth, it's not just a memory. It's a return to a point on the line. And when you imagine being older, wrinkled, sipping tea and staring out the window, it's not just a hope. It's a part of the structure already drawn. And when you dream, well, maybe dreams are what it feels like when your flashlight jitters, when it skips slices and lands somewhere unexpected, somewhere deep in the loaf. You are a worm in space-time. And that's not sad. It's beautiful. Because it means you are never alone. You are surrounded by yourself, held in a ribbon of moments. Every version of you whispering to every other I was here too. And tonight, as you sink deeper into stillness, remember this. You're not going anywhere. You're already there. Already everywhere you'll ever be. Quantum clocks and gravity games. You've been pretty polite so far, letting the universe unravel at a cozy pace. But now we're going microscopic, really microscopic, where time starts to act less like a river and more like a twitchy squirrel with commitment issues. Let's talk Planck time. This is the smallest meaningful unit of time. It's around 539/10 seconds. That's a decimal followed by 43 zeros, and then a 5. It's so tiny that comparing it to a second is like comparing a second to the entire lifespan of the universe. If time were a movie, Planck time would be the smallest possible frame before the universe stops making sense. Below that, physics throws up its hands and goes, I got nothing. This matters because it hints at something wild. Time may not be smooth. It might be quantized, made of tiny, indivisible bits like pixels on a screen. You zoom in far enough, and the flow becomes choppy, jittery, discrete. Like an old flip book with missing pages. Odd fact break: in 2020, researchers at the University of Vienna built a quantum clock so precise it could detect differences in time between 2 points, just a millimeter apart, in Earth's gravity. That's right. One end of a clock ticked differently than the other. Gravity changes time that sensitively. So now we bring in quantum mechanics, the chaos gremlin of physics. Everything in the quantum world is uncertain, probabilistic flickering between possibilities. A particle doesn't have a position until you look at it. A cat is alive and dead in a box somehow in your imagination and your science. Now slap that uncertainty onto time itself. Welcome to quantum gravity, the great unsolved mystery. Scientists are still desperately trying to unite Einstein's smooth, bendy spacetime with quantum theory's disco ball randomness. So far, no one's cracked it. But there are contenders. Ideas like loop quantum gravity, where space and time are woven from tiny loops like a cosmic chainmail. Or string theory, which says particles are tiny vibrating strings and spacetime emerges from how those strings dance. What they all share is this suspicion spacetime might be not fundamental. It might just be a convenient illusion, a blurry averaged-out story we tell ourselves to make sense of deeper processes. Imagine time is like the color orange. Real to your eyes, yes, but actually just your brain interpreting a certain mix of light frequencies. Beautiful, but constructed. Quantum time might be that way too. A construct emerging from deeper, unknowable rhythms. Scientists still debate whether time actually ticks at all, or whether what we perceive as moments passing is just changes in correlations between particles. If you're confused, good. You're in excellent company. The leading thinkers in the world are just as baffled. And maybe that's the point. You can't sleep in a lab after all. But you can sleep in mystery. Here's a quiet joke to fold under your pillow. Why did the quantum physicist refuse to tell you what time it was? Because the more precisely they knew the time, the less they knew where the clock was. Let's return to gravity for a moment. You remember from earlier, gravity slows time. But in the quantum world, gravity becomes a jittery mess, not a smooth force. Trying to combine quantum effects with gravity is like teaching a cat to swim in a lava lamp. They're both moving, neither behaves, and the result makes no sense. But we're trying. In fact, scientists are building space-based quantum clocks firing lasers at atoms in orbit, just to measure teeny differences in gravity's grip. Because somewhere in those tiny ticks, they hope is a clue. A glitch in the matrix. A signal from the foundational code. And if they find it, time might crack open like an eggshell, revealing something stranger underneath. Something timeless. Or beyond time. Or just very, very weird. So tonight, as you lie there listening to the steady rhythm of your breath, know that even that rhythm, so solid, so present, is built from uncertainties. Your cells, your molecules, your atoms, your subatomic particles, they're flickering, buzzing, dancing in probabilities. Not being in time, but participating in the illusion of its passing. And you're the chorus they create. So close your eyes. Let the quantum clocks do their thing. Let gravity nudge your heartbeat slower. And trust that even if time is broken into a million mysterious pieces, you're already whole. A vacuum full of something. You've probably heard the phrase empty space. It sounds peaceful. Zen. Like the nothingness between stars, or the void beneath your bed, or the awkward silence after you accidentally wave back at someone who wasn't waving at you. But let's be clear, space is never truly empty. In fact, the vacuum of space is one of the most active, chaotic, ridiculous things in the universe. It just hides it well. Even when there's nothing there, no atoms, no molecules, no dust, not even light, the vacuum boils. Quantum physics says that emptiness isn't really empty. It's filled with virtual particles, tiny pairs of matter and antimatter that pop into existence for a fraction of a second, collide, and disappear again, like bubble wrap popping beneath the fabric of space-time. They're called virtual because they're not directly observable. They don't stick around. But their effects, they're real. Odd fact break, the Casimir effect is a spooky little experiment that proves the vacuum isn't empty. If you put two metal plates very close together in a vacuum, they will mysteriously attract each other because the energy of virtual particles is different between the plates than outside them. You can actually measure the push of nothing. So yeah, nothing pushes, nothing flickers, nothing buzzes with energy. Your room even now in its sleepy silence is teeming with virtual activity. Billions of tiny ghost particles springing into being, then vanishing like stage magicians in a fog machine. And this froth of nothing might be the foundation of everything. Many physicists believe the energy of empty space called vacuum energy could explain dark energy, the force that's causing the universe to expand faster and faster. Imagine the whole cosmos being stretched outward by the restless breath of the vacuum itself. Scientists still debate exactly what this vacuum energy is, or how much of it there is. In fact, quantum theory and cosmology give wildly different numbers, like off by 120 orders of magnitude. That's the biggest disagreement in all of science. It's like asking two people the population of a city, and one says 23 and the other says all the atoms in the universe. Something's off. But that's what makes this beautiful. The vacuum might be the biggest clue we have that space-time as we know it is not the final layer. That underneath it all, beneath your bedsheets, beneath your heartbeat, beneath the fabric of the cosmos, is a deeper field of quantum information, still beyond our grasp. There are theories that space-time itself emerges from patterns in this field, not built atop space and time, but rather, space and time are built atop it. That's like saying the ocean isn't made of water, it's made of pressure waves. Or that your dreams are made of shifting clouds, not thoughts. Here's a light joke to accompany the darkness. What did the virtual particle say to its twin? Sorry, I ghosted you. Literally. So what are you lying in? Not just your bed, not just your room. You're floating in a seething sea of quantum foam, stitched with potential, rippling with energy you'll never directly feel. And yet, you do feel it. Every second this vacuum buzz contributes to your life. The electromagnetic forces holding your atoms together, fed by this restless quantum backdrop. The light you see, the particles in your phone, the glow of your screen. None of it would be stable without the jittering vacuum underneath. You owe your existence to the not quite nothing of space. There's even a theory, quantum fluctuations in the early universe, that says our entire cosmos was born from a random hiccup in the vacuum. A quantum burp that inflated into galaxies, stars, you. So if you've ever thought I came from nothing, that's kind of true. But nothing is far more alive than we realized. And if you feel small tonight, like a tiny point floating in endless dark, remember the dark is not empty. It's filled with light that hasn't happened yet, particles that never quite were, and futures that just might be. So rest. Let the vacuum cradle you not as a void, but as a birthplace. Let the ghost particles buzz around your dreams. Because even the silence of nothing is singing with everything. Why time might be an illusion. You've been following time your whole life. It wakes you up, bosses you around, reminds you of birthdays and missed calls. It feels like the most fundamental thing in the universe, an invisible highway pulling you from birth to bedtime. But what if it's not real? Not just a little weird or hard to measure, but fundamentally not a thing. Just a story we've been telling ourselves. Like Bigfoot, but with alarm clocks. Let's rewind. So far we've treated time like something that flows. But in many physics models, time doesn't really flow. It just is. Everything exists in a giant cosmic loaf, remember? Past, present, future, all slices. No movement, no ticking. So if nothing is actually moving, and time is just the ordering of events, then what you experience as now is just one static page in an already finished book. And here's the unsettling twist. There's no reason from physics' point of view to say that the present moment is any more real than your 5th birthday or your future grandchild's nap. They're all just coordinates in space-time. Odd fact break. In some approaches to quantum gravity, like Carlo Rovelli's thermal time hypothesis, time is not a fundamental feature of the universe. It emerges only from the thermodynamic behavior of systems. Meaning time is something that shows up when things get messy. No mess. No time. So, is time real? Well, it depends. Real to your brain. Absolutely. You feel it. You react to it. You dread it and long for it. But real in the same way atoms are real. Maybe not. Some physicists think time is a convenient illusion, a way our brains stitch together sequences of change to make sense of experience. A trick of memory and entropy, like a magician misdirecting your attention while pulling doves out of nowhere. Others go further. They suggest that time and even causality might not exist at the deepest level. Just correlations between events. You eat the soup and the spoon falls, but the order might be a perception. This is the heart of timeless physics, a radical approach where equations don't even include time. They just describe relationships, probabilities, and states, and our experience of time. Just a side effect of our limited perspective. Scientists still debate whether this means the future is already written, or if we're generating reality one moment at a time like a Minecraft world being rendered in front of us. But either way, the version of time you live by, the clocks, the calendars, the constant running toward or away from things, that version may not survive a deeper look. And if time is an illusion, then so is waiting, so is rushing, so is that little ache that says you're losing time or wasting time or running out of time. Because if all moments exist, they're never really lost. They're just in another part of the loaf. Maybe that's why some people feel like they've already been here before. Déjà vu, déjà rêvé. Maybe it's a glitch in the projector. A moment flickering across your mind out of sequence. Or maybe it's the universe reminding you this moment too is eternal, already part of the shape. Here's a sleepy joke to let your neurons cool. Why did time get kicked out of the party? Because it kept showing up in everyone's personal space. So what do you do lying here in a possibly fake timeline? You let go. Let go of the pressure to be on time, to be ahead, to be late. Let go of past you judging now you. Let go of the illusion that time owes you anything. You're not falling behind. You're exactly where you are. Which, by the way, is always true. So if time isn't real, then this moment doesn't have to be just a dot on the highway. It can be a whole universe. Complete, unmoving, timeless. And maybe, so can you. Space-time might not be real either. I know. It's a lot. We've already flirted with the idea that time is a convenient illusion, a side effect of entropy and memory. But now we go further off the edge of the map, where even space starts to dissolve beneath your feet. Because what if space, like time, isn't fundamental? What if it's not the base layer of the universe, but just a pattern? We perceive the way information arranges itself when we try to understand it. There's a growing idea in theoretical physics, echoed in string theory loop, quantum gravity, and the baffling but brilliant field of holographic principles that space-time, this smooth, stretchy fabric we've been so cozy in, might emerge from something deeper. Something not even in space or in time. Something spaceless and timeless. One proposal, that space is just the illusion that emerges from the entanglement of quantum bits, tiny pieces of information tied together in a web of mathematical intimacy. You might know about quantum entanglement. Two particles become linked in such a way that if you measure one, the other knows instantly, even if it's a galaxy away. Einstein called it spooky action at a distance. But what if that's not a bug in the system? What if that is the system? What if the geometry of space, the distance between things, is just a way of describing how much information they share? If they're entangled closely, we say they're close in space. If not, we say they're far. So space might be nothing more than a map of relationships between quantum bits of data. Odd fact break. The ADS CFT correspondence, one of the most celebrated discoveries in string theory, shows that a universe with gravity can be fully described by a theory without gravity living on a lower dimensional boundary. That's right, our 3D world might be a projection of math scribbled on a 2D surface we'll never touch. This is known as the holographic principle. It says that everything inside a volume of space might be encoded on its surface like a hologram. Your body, your memories, the moonlight on your pillow. All of it might be a shadow of deeper structureless math. So not only is time up for debate, space might be too. Scientists still debate how to fully define space from entanglement, how to go from numbers to shapes, from bits to geometry. But the consensus is rising like mist. The real world may not be spatial at all. Space is just how we, as slow, squishy beings, organize what we experience. So if you can imagine a place without space, do it now. There's no direction, no size, no near, no far. There is only information, patterns, links, interactions. And your body, your breath, your thoughts, they're not in space. They are space temporarily expressed as ripples in this entangled web. Here's a sleepy joke to tangle with. Why did the entangled particles break up? Because one needed space and the other didn't believe in it. So what happens when you lie down at night? You feel the bed. You see the room. You experience space, Joe. But maybe that's like seeing color. It's not out there. It's a brilliant, useful hallucination created by your brain to help you function in a world too complex to grasp raw. Maybe space is user interface, like icons on your phone folders and apps that help you function even though you're not really dragging files across a desktop. You're poking at code with visual metaphors. Likewise, you navigate life using space because you're not equipped to grasp the underlying data stream. So tonight, as your body fades into stillness, realize your location is not a place on a map. It's a state in a web, a node in an unfolding tapestry of patterns. You're not in space, you're part of the illusion of space. And that illusion, it's beautiful, it's useful, it's soft, and it cradles your body like memory foam. But beneath it, something wordless hums. So close your eyes. Let space dissolve. Let the shapes lose shape. Let the here become nowhere. Let the illusion fade into the warmth of your own awareness. Because the deeper you go, the more you realize you were never really here. You just thought you were. So, where are you really? You lie there now, quiet, soft, and strange. You think you're in your room, maybe in bed, maybe curled on the couch. You think you're somewhere specific in time and space. But let's be honest. If time isn't fundamental, if space isn't real, if your body is just a thread in a four-dimensional sculpture, and your breath is a brief ripple in a sea of quantum fog, then where are you? It's a question that philosophers and physicists both whisper about, usually when everyone else has gone to sleep. When the lights are low and the chalkboards are full of equations no one fully believes. Because the deeper we look into the universe, the more we peel back the layers of clocks, rulers, atoms, and equations, the more the idea of being somewhere starts to dissolve. Maybe you're not in space. Maybe you're not moving through time. Maybe you're just awareness riding the illusion of motion across a dreamscape that never truly began. Odd fact break. Some interpretations of consciousness, like integrated information theory, suggest that you aren't tied to your body or your brain, but to patterns of information and how they interact. That is, your location isn't here in the physical sense. It's wherever this informational pattern happens to resonate. That sounds poetic, but it's also terrifying. Because it means the you think you are the one trying to fall asleep, the one worrying about texts you haven't sent, or socks you haven't folded, is only a surface-level persona, a character. The deeper self, the one truly asking, "Where am I?" might not even know what where means. And scientists still debate what to do with that. Some say we'll never solve it. Some say it's the final puzzle piece, the unifying theory of consciousness and physics. Others say we're already too late chasing a shadow that keeps shifting as soon as we try to measure it. But here's the thing. Not knowing is okay, because not knowing is true to experience. Every moment you've lived has been filtered through mystery. Every kiss, every heartbreak, every bowl of soup has been stitched together by a sense of presence you never fully understood. You were never sure where you were. You just were. And in some strange way, that's enough. So here's one last sleepy joke before we close the book. Why don't physicists play hide and seek? Because good luck hiding when location is still a matter of debate. Now rest. Rest knowing that all you're trying, all you're reaching, all your plans and memories and dreams exist like ripples in a field more vast than space, more silent than time. You're not lost. You're not behind. You're exactly where you've always been, inside a mystery big enough to hold you. Close your eyes. Let the ticking stop. Let the walls fade. Let the idea of where blur into stillness. Because the moment you stop asking where you are, you arrive. And that arrival has no destination, no deadline, no coordinates, only the quiet truth that you were here all along. So here you are, traveler of thoughts, dreamer of dimensions. You've wandered through space and time not as fixed realities, but as flexible ideas. You've stepped between particles, danced along the curve of gravity, and stretched out across space-time like a worm of memory and possibility. We asked whether time was real and found it might only be entropy's song forward, but not certain. We held seconds in our hands and watched them vanish, tried to define now and realized it always slipped away. Even the emptiness between stars turned out not to be empty at all, but full of hidden dances and flickers of unseen particles. You learned that space might just be a network of relationships, that your bed, your walls, your very sense of location is a kind illusion, that everything you've ever felt could be ripples in a deeper, non-spatial field of information, that the you of yesterday and the you of tomorrow aren't gone or waiting, they're just other frames in the reel, and still the most beautiful mystery remained. Where are you really? Not just in this room, not just in this second, but in something larger, something spaceless, something timeless. A quiet place that doesn't need answers, only presence. So sleep now. Let the questions keep breathing beneath your dreams, because whether or not time exists, you do. And in this moment, in this gentle letting go, that's more than enough. End of script. Good night.